All right, folks, it's Bass Action back in action here. In this video, we are going to go through different methods of solving quadratics, specifically without a calculator. In class, or you can try this before class, we also want to look at verifying the solutions using our graphing calculator or Desmos. So we will talk about that, but you don't need to do that here in this video. For right now, we want to focus on solving without a calculator. Intercepts would typically be written as ordered pairs. I may or may not do those that way in the video, but we'll see how this goes. Okay, first let's talk about factoring, specifically factoring with a leading coefficient. You do need to be able to factor with a leading coefficient. You can do that with guess and check or any other method that works for you. But the first step, no matter what you're doing, it needs to be to move everything to one side and set the equation equal to 0. Now, if you are a fan of split the middle or the box method, I'm going to quick write that out here. This would be our box method. We would put our 6x squared here. I would put my -5 here. Then I would look at this and I'd say I'm trying to multiply to a -30 and add to a -7. That would be a 10 and a 3. So I would do a -10 and a +3, and then I would start factoring the greatest common factor from each row and column. So working left to right, I would end up here with a 2. Oh, I should have put an x here. Sorry, forgot to put the x there. I'd put a 2x. Then I would get a +1. Top to bottom, I would get a 3x. Top to bottom, I would get a -5. Now, personally, I would do this one with just a guess and check. Definitely works because my constant is a prime number. So this would give me a 3x and a 2x, and now I just need to decide whether it's where the 5 and the 1 go. So it doesn't really matter which way you do this. I'm going to go ahead and put my -5 and my +1, and then we can check this. So this would give me a +3. This would give me a -10. -10 and a +3 gets me back to my -7. Notice that these factors here are the same as the factors that you have on your box. So if you're not comfortable with either one of these methods, I need you to come and talk to me so that we can work on this practice and I can give you maybe a slower lesson for this. Continuing on to our solving, this would give our solutions as 5/3 and a -1/2. But as I mentioned earlier, x-intercept should be written as ordered pairs. So this should technically be written like this. We should write these as these ordered pairs, these nice real solutions as points on a graph. If I give you an assessment, I will be specific of whether or not I want those written as ordered pairs, but it is a good concept to remember. Now, solving by square roots. Our clue on this problem that solving by square roots is a good method is because we can see that we have this entire expression here, this entire component that is a quantity squared. If we can eliminate this 5 from the left-hand side, we will easily be able to solve this with square roots. So let's do that first. We're going to divide by that 5. That's going to give us a 4x - 1 quantity squared equals 9. Then we'll take our square root of each side. On the left-hand side, that leaves us with a 4x - 1. On the right-hand side, that's going to leave us with a ±3. Now, I'm going to go ahead and I'm going to move that 1 to the other side, so 1 ± 3. And then from here, now that I'm ready to actually divide by this 4, I would go ahead and split this into its two equations. I would say 4x equals, and I'm thinking 1 + 3, so 4x equals 4, or x equals 1. Or the other method would say, or the other route, I should say, is 4x, and now it's 1 - 3, so 4x equals a -2, so x equals a -1/2. These would be our two x values, and again, we could write those as ordered pairs if we wanted to do that as an x-intercept. The next thing that I want us to look at is completing the square. Completing the square will end up with solving by square roots in its last little bit. We start with completing the square, we end with square roots. So I'm going to write my first step for this so you can see what this would look like. The first thing that I'm going to do is I'm going to take the quadratic and the linear term, and I'm going to factor that leading coefficient, not the GCF. I'm also going to take the constant and move it to the right-hand side. So if I do that, I have 4, and then I have x squared minus 6x. Notice it was just the coefficient. And then I like to actually insert and draw these little blanks. Then I'm going to have a negative 21 plus this blank. This is what I like to do for my first step. The blanks help me remember to balance, and we're going to specifically factor out that 4. Now, to determine what goes in this first blank, we're going to take this negative 6, and we're going to divide by 2. That's going to give us a negative 3. Then we're going to take that negative 3, and we're going to square it, and that gives us a 9 right there. Now, to balance the equation, everything in the parentheses has to be multiplied by 9. So to balance the equation, I actually need a 36 on the right-hand side. From there, I can say 4. And then if we factored this, this would be x minus 3 times x minus 3. Yes, it is this minus 3. That gets written as x minus 3 quantity squared. The right-hand side is now a 15. What I want you to notice is that these two problems are very, very similar now. The biggest difference is that up here, when we divided by 5, we got a nice 9. Down here, when we divide by 4, it is not going to clean up so nicely. That's okay. We are not going to write a decimal. This gives us an x minus 3 squared. I'm going to leave this as a 15 over 4. Square root, square root, square root. I want to really emphasize writing those two square roots separately. The left-hand side now becomes x minus 3. The right-hand side becomes plus or minus the square root of 15 over 2. So our answer is 3 plus or minus the square root of 15 over 2. And again, if we wanted to write this as its formal intercept, it would look like 3 plus or minus the square root of 15 over 2, comma 0. So if we wanted to fully write those as the intercepts, we could do that. The last thing we're going to look at here is the quadratic formula. I do not want you generally using the quadratic formula unless our numbers are kind of big, maybe decimals, or you have a calculator. We need to be comfortable with the non-calculator methods. But let's just review quadratic formula. X equals negative b plus or minus the square root, b squared minus 4ac. This entire expression is all over 2 times a. The a, the b, and the c are the coefficients on the quadratic, the linear, and the constant. We can go ahead, we can substitute this in. So negative b is going to be a positive 2 plus or minus the square root. I like to square the b squared right off the bat. Negative 2 squared is 4 minus 4 times a times c all over 2 times a. Now as I keep working on this, I'm going to have 2 plus or minus. This one's not bad to do without a calculator. 4 times 4 is 16, so I have 4 minus 16 gives me a negative 12. And this is all over 8. What I want to emphasize here is this negative 12. This negative 12 is this b squared minus 4ac, and this is called the discriminant. Notice that we now have a negative number under our radical, so we are going to need to work with our imaginary numbers. At this point, I'm going to go ahead and simplify or separate. So I'm going to have my 2 over 8. Oops, that's not what I meant there. Let me get rid of that. There we go. Got my 2 over, it does not want to switch for me. X equals 2 over 8 plus or minus I square root of 12 over 8. Keep going. 1/4 plus or minus my square root of 12 becomes 2I square root of 3 over 8. And we'll simplify one more time. 1/4 plus or minus square root of 3. Now that I can be written in the front, or sometimes students like to write it in the back. That's fine. All over 4. So this is our final answer for our quadratic formula. Now, just to recap, we need to be comfortable recognizing that these 3 methods are the main methods that you need to use when you do not have a calculator. The quadratic formula is useful, but in particular, really only when you have a calculator. Otherwise, there are too many common mistakes that we can make on that.